So the last video we want to do before the test is quickly go over parabolas and semicircles, or namely half a parabola and semicircles. Now, you automatically know if you have half of your graph if you have a square root in the function, okay? If there's no square root, it's not half a parabola, okay? But if there's a square root, it should be half a parabola or a semicircle, okay? That's very important. Now, the other thing is sign in front of the radical is very important. And this is because it tells you what half you want, okay? So that's why it's so important, because you need to know which half you're drawing. You can't just draw both halves. That's not going to work. And if you do that on the test, it will mark you wrong, because we want half of it, not a whole one, okay? So when we're going through this, keep in mind, these all are going to have radicals in them, namely square roots. So that's why they're half, okay? And the sign in front is going to be super important. So let's look at y equals square root of x. This is half a parabola because there is no square under the radical, okay? So as soon as you see that, you know it's a half a parabola, because remember, parabolas only have one squared term. So if one side is got the square root on it, that means that the other one has to be a squared term, right? You can't have y equals square root of x and then have it be a circle or something like that. It has to be a parabola if it's a single degree, just like it is here. So it's y equals square root of x, not y equals square root of x squared, okay? So we know half a parabola. The other thing is, notice that it's a positive sign in front of the radical, okay? Now, I know you want all positive y values because it's y equals and positive in front of radical. And so the last thing we need to figure out is, what would the vertex of this parabola be? The fastest way to find the vertex is to solve for the full parabola equation. So we square both sides and we get y squared is equal to x. This means we have a horizontal parabola, right? Because y term is squared. And so looking at it, it's in standard form already. So my vertex would be 0, 0. And then to graph it, all I would need to do is just remind myself, okay, so I have a vertex of 0, 0, and I only want half of this. I don't want to draw the whole thing. So I go back to that second arrow that I've got, and notice that I said all positive y values because it's y equals and positive in front of radical. So that means that my graph is going to be all positive y values, which would be above the x-axis, okay? And that's it. That's your graph of your half of parabola. Now let's look at a different example. Let's say this time it's x equals square root of y. Again, this is half a parabola and not a semicircle because no squared term under radical, okay? And then I need to know which half do I want. And I notice that I want all positive x values because it's x equals and it's a plus sign in front of the radical. Okay, so I know I want all positive x values, so I only want positive x values on this one. And then I need to figure out vertex. But to find vertex, all I need to do is figure out what my original parabola would be. So x equals square root of y. To solve this, to make it look like a standard parabola, I'm going to square both sides. I get x squared is equal to y. So this is a vertical parabola. Because x term is squared. And vertex is 0, 0, going off of what my standard equation would look like, right? So then knowing my vertex is 0, 0, and then I only want positive x values. Now, if you look closely, these are all negative x values, these are all positive x values by standard convention. So I want this side. And that's it. Now let's move on to semicircles. So looking at this equation, y equals square root 16 minus x squared, I know I have a semicircle because we have a square term under radical. Okay, so if you notice, it's 16 minus x squared. And then, just like with the parabolas, first thing I do is figure out is what part of the semicircle do I want? I want all positive y values because it's a y equals equation and it's a plus sign in front of the radical. Okay, so the last thing I need to do is I need to figure out my center, right? And I need to figure out my radius because that's going to determine how big my semicircle is going to be and where it's going to be. So to figure out center and radius, I solve my equation to get it into standard form for a circle. So I square both sides, and I get y squared is equal to 16 minus x squared. This is not completely standard though, right? Because I need to get x squared plus y squared, so I'm going to add x squared to both sides. And I get x squared plus y squared is equal to 16. So this means my center is 0, 0, and my radius is 4. So I plot my center, and I know my radius is up 4, to the right 4, to the left 4. And then if you're wondering why doesn't she mark down 4, it's because we only want all positive y values, which would be this section only. So I only want that part of my circle. Okay. Last one. Now let's look at an equation where it's x equals square root 16 minus y squared. Looking at this, I know I have a semicircle, right? Because of square term under radical. So that would be y squared. Right here, okay? So I know I have a semicircle just from that portion. So the next thing I need to do is need to figure out which part of the semicircle do I have. So in order to do that, I'm going to look at my equation, and I say that I want all positive x values. And this is because it's an x equals equation, and the positive sign in front of the radical. Okay, so I've done the first part. Next thing I need to do is I need to figure out the center and the radius. And in order to do that, I'm going to get this into a standard form for a circle. So in order to do that, I'm going to square both sides, and I get x squared plus y squared equals 16. So my center is 0, 0, and my radius is 4. So I plot my center, and then my radius is 4, 4, and 4. Now you're probably wondering, well, why did she move 4 to the left? And that's because, if you remember in the second one, I said I only want all positive x values. These are all the negative x values. So I'm only going to mark this side of the coordinate axes because I want all positive x values. So my circle looks like that. And that's it. Okay, that's how you figure out half parabolas and semicircles. And I hope this helped. Please let me know if it didn't or did not. I really want to make sure you guys understand this a little better than you did today and yesterday.